Hello guys, welcome back to my YouTube channel. So in this video, I'm going to explain the covering problem in another practice. So in this practice, there is such a limitation that every proposed facility has the limitations. In my previous video, I used a binary to to help in choosing the multiple facility that should be built and should be served in my current facility that already set. But now we have another problems that each alternative has the limitation, especially the capacity. So let's say I have a cell phone tower site. I have 8 towers, and each tower only serve a specific number of the capacity. And I have a zone. The zone represents an area that should be served by the towers. And then I have different kind of tower that serve different zones as well. For example, towers number 1 only serves zone number 1, 2, and 10. They only serve 3 zones. So the remaining zone has not the remaining zones have not been set with another tower that should be they should be served as well, since it probably has a demand in installing the phone infrastructure, for example. So to overcome the problem itself, let's begin with a new algorithms. So the algorithm is greedy algorithm. So greedy algorithm start by summarizing and do some calculations. It is actually very easy to do so because you just only create a tables that similar with the total covering problems, but the difference is just like finding the largest facility that could serve many existing facility. So that's the point. So all you have to do is just like sum the cover coefficients. So each number represents the limitation capacity. For example, zone number 1 only serve 50 customer in zone number 1. And the first tower only serve 25 customer in the second zone and do the same actions. And all the tower site has a limitation in serving the customers numbers. So just do the sums, just sum all the cover coefficients, all the customers numbers in each columns, and repeat until all the towers already calculated. And after that, find the largest one. It means it covers many customers. So if the facility could serve many customers, it should be get prioritized to be built immediately. So we can see that the tower number 2 as the first solution to be built, and the remaining zone should be set by another tower which can be found in the next iterations. Okay. And after we identified, and then we do some elimination rows. So just eliminate the row which has connection with tower number 2. It means tower number 2 could serve zone number 1, 9, and 10. So we can eliminate the row. So it means I have only new table that has smaller zones because the previous zone already served by the second towers. So we can move to another table and just repeat the greedy algorithm by sum the remaining numbers capacity and do the same action as tower number 8 and everything will be identified or calculated. And then do the similar action, just like finding the largest numbers, which represent that the tower could serve many customers. And after that, just eliminate the row that has strong connection with the towers number 4, which is 8, 7, and 6. So we can eliminate the row. So maybe you can do more accurate than mine because I use the mouse. And then we got a new table that includes maybe a small zones, including 2, 3, 4, and 5. Zone number 2, 3, 4, and 5. So this remaining zone will be set by the towers in the next iterations. So it's very easy, right? Just like do calculations and do some of the coefficients and finding larger, just eliminate the row and everything will be so easy to do so. So I have a new table now. And yeah, just do the same step. Sum the remaining coefficient, which represent the customers, and do until all the column are already identified or calculated. And by this state, I get the same numbers, the same largest numbers, which belongs to tower number 3 and number 8. So number 3 and 8 will be just like the third alternative to be built. So it means they can serve many zones. Okay. If I choose tower number 3, it will serve zone number 3, 4, and 5. And if I choose number 8, it will also serve the same zones. If I eliminate the zone, so we can see, the remaining zone will be zone number 2. So the last step is finding the last tower that could serve all zone. So we have some alternative, just like choosing site number 2, 4, or 3, or choosing tower site number 2, 4, and 8. And for the last zones, we see that zone number 2 has not been set. So to connect with the towers, so we just do quickly because it will be served whether zone number 1 or zone number 6. So that's the answer in covering problem for specific limitations.